Good morning, ladies and gentlemen. As we start with the deck, let me go through a quick self-introduction. I'm Sreekumar. I head the Chief Growth Office for BNB Security Automation. We are based out of Bangalore and Kuala Lumpur. We are into building automation and building management systems. We need to collaborate with a lot of companies within KL. That's where we are. Over to Jacob.
Hi, my name is Jacob Wolfe, and I work for Armstrong Fluid Technologies. We manufacture everything from smart pumps to other components for a data center and all the way up to a modular chiller plant. So we're experts in modularization, and I handle our hyperscalers globally. So I come from the heat transfer industry, and I'm happy to be here.
Thanks, Jake. It's a pleasure to have you here. And with your vast experience in hyperscalers, today we know one of the biggest concerns is how do we know or catch up with the thermal cooling of data centers with the exponential growth of AI loads on DCs. And the first question is, where are the cooling liquids going in terms of data centers?
So I believe in one of the prior presentations, we see that the racks are going from 10 kilowatt, and we've seen them up to 125 to 130 kilowatt. So luckily for me, I've worked in heat transfer for a long time, and you need to be able to dissipate that heat, you have to use water. And so liquid cooling is here, and we've seen immersion cooling, we've seen direct-to-chip cooling. I could say globally, with what I do, that direct-to-chip has become a little bit more popular. And so that's what we're seeing currently. I think, and we'll probably talk about it a little bit more, what's the future after that? Because with Moore's law, everything is getting more dense and dense, especially with AI. It's crazy.
So there are two related questions. One is that what to do with the tropics? Malaysia, Singapore has got already a high ambient temperature. So what would be the more preferred? Is it the warm water cooling or the D2C?
So it's a great question. Global warming is affecting all regions, and I've worked in the refrigeration industry and other industries, and what I see is that whenever you design a system today, you can put it in the north, you can put it in the south in a tropical climate, but thermodynamics is thermodynamics. Absolutely. And so if you look at all the components and they're rated at the right pressure and they're rated at the right temperature, right now I know in an area, just taking myself for example, 10 years ago, in a certain area in one region, it was a certain ambient. Today, we're rating equipment at 20% higher for the worst case scenario. So, you really just have to make sure that you cover that one day in 50 years, because unfortunately, that day now comes with a lot of the customers.
The worst case scenario, right? Yes. The worst case scenario. Okay. And what's Armstrong's experience in the Southeast Asia? What have you been doing here in the space?
So it's actually in KL, which I handle, it's actually becoming quite familiar to the US. And we're seeing extremely rapid growth in both regions. And modularization is really becoming a key to that. And there's very specific reasons. And from my standpoint, in where I handle everything, you're able to deploy quicker, and there's also testing benefits as well. So whenever you do a stick-built facility, if there's one piece or one version of let's say a control panel, and you put it on 120 CDUs or 120 chillers, you got to fix that on site. Modularization, you make a first of a kind, and then you test everything, you performance test it, you test all the controls, and so when it goes out to the site for the client, it's a lot easier of a commissioning process. They like that. And speed to market is everything. I think a lot of people don't realize the faster you get the data center up and running, the faster the machines start learning, and that is a competitive advantage.
And now we go to the most tricky question in terms of growth. What's the board concerned about in terms of the composite usage index, be it the PUE or the CUE or what's your stance on that?
That's also a huge question, because what I see, depending on the country, depending on the region, wherever it is, power, water, and sustainability are really the three main topics. But what we're seeing is now in certain areas, you don't have power, or you only have a certain kind of power, whether it's renewable or not. And then in some regions, you don't have water. And water for me is probably becoming the biggest resource. It's being heavily scrutinized because whether it's a dry data center using an air-cooled chiller or especially if it's a water-cooled chiller, which will be much more efficient, especially in a region like, KL. But the problem is you got to have redundant water on site. And a lot of places, regardless of where it is, they don't like that. And so, looking at a different type of heat rejection, there's certain areas where I see where cooling towers is a standard, like in say, KL or Southeast Asia. And now we're seeing adiabatic coolers put in, even though they might take a little bit more power, but they have power there. They just don't have water. So it's kind of a give and take.
Going a little more technical in terms of hydronics, what do you think, given the circumstance of different geographies in terms of how they're scaling up the data centers, what do you think would get more traction in terms of the kind of hydronics?
So it's going to be no different whether it's in a humid climate or tropical climate like KL or in, our home base is Toronto. Every data center is going to be roughly 40% air-cooled still, and 70% AI to cover everything. The trick is that if you have a data center that's being built it could be 9 months, it could be 2 years to build out that data center. Some data centers are 1.5 square miles that I deal with. What you need to make sure is that when you start the data center, if you're using single-phase direct-to-chip, after a year, if they want to install a new type of chip, you're probably going to have to look at two-phase. But you need to keep the consistency and the flexibility to use a technology that you can get in there. So if you start with immersion, then just stay with immersion. If you start with direct-to-chip, you're probably going to have to keep it. And I'm not an expert completely, but that infrastructure would have to be the same, and the customer needs to be flexible for that. So they'll probably have to be more dense 2 years if that's when they want to start.
Okay, that seems to be a kind of a catch-22 because when the pressure on ESG metrics kicks in, and if you say there is hardly little time to switch over to D2C, I'm sure there's going to be a lot of pressure on the clients and also the service provider.
Yes.
Have you seen any examples anywhere where this happened across the world in your experience?
From what's that? So when
The switch over from when the chip changes, you move to a two-phase D2C.
So we don't see it directly, but where we get pushed is on deployment. So if that were to happen, then we get a call to say we need to move up our time frame, so they have the time to potentially change infrastructure, and so we can scale that out for them, if that makes sense.
Right.
So it's to your point, it's a double-edged sword. It's very complex, very complex. The other issue that the AI has brought to the table is standardization, whether it's controls, whether it's a big piece is thermal. So every one of these OEMs, manufacturers, at some point you're going to have a chiller there that's AHRI rated. Then you're going to have equipment on the hot aisle containment that's going to have a certain electrical rating. Then you have a CDU, which this market is booming right now. Everyone, there's factories in here backed up for 2 years, but the industry has an issue in that CDU isn't rated yet. And it's a heat transfer device. The new technical water fluids that are whether it's dielectric fluid or glycol with some inhibitors, those fluids aren't in the AHRI program. So I know that a lot of OEMs that we work with, they're going to have to go through that process because the only remedy is for the end user to factory performance test every CDU before it gets deployed. Because they can't have 100 of them on site, and then when they put this fluid in, if the heat exchanger, which a CDU is really just a heat exchanger, it's no different than district heating or district cooling. It's just a heat exchanger. That's the most important piece. And I do come from the heat transfer industry, so I'm a little biased, but that is really important because I have seen that in the field where something hasn't performed because it wasn't rated with that fluid. So you're going to end up seeing some sort of a performance test where all these CDUs are eventually going to have to be AHRI rated or something similar to that. Like a CTI certification for a cooling tower, or Eurovent would be another one as well.
So a follow-up question, Jake. Now, when 3M actually comes out of the PFAS, what do you think? Does Malaysia have a chance of bringing some palm-based ester cooling liquids? Have you heard of something like that? Are there any substitutes coming in?
With 3M leaving that market, the one thing that I see is all of the data centers and Malaysia is a huge market, and you got a lot of hyperscalers, especially from the U.S. that are coming in. The EPA is going to heavily regulate any PFAS gas.
Absolutely.
Very much. And I went to a data center in Loudoun County, Virginia, which is the largest data center market in the world. And it was an event like this, and I had to walk through about 300 protesters because they didn't want it in their backyard because it doesn't look pretty. But the government is now, just like they did with the refrigeration industry, supermarkets, and industrial refrigeration. They're looking at the data centers, whether it's to reclaim the heat off the data center, which is already being looked at in Germany and also in Washington State and Oregon State. But at some point, KL will have to do that as well, especially if it's a U.S.-based company, because it's all going to wrap up into one ESG document going to, that they got to publish.
That's true.
Yeah.
We just spoke about the ESG. Where do you see the talent building up for these massive scaling up of AI density data centers? Are there? I know in the US, the talent availability is not a huge challenge. But where do you see that in the Southeast Asian countries? Any insight there in terms of the talent to come in?
Yeah, I mean that's one reason why the whole U.S. market went modular. There's not enough workforce to install everything. It's just so massive. We have all of the jobs that I work on. I'm working with 3 of my competitors, and we have to work together to get everything done because we all don't have the capacity, and there's not enough labor. And I would see that that's going to happen with. I'm already seeing it happen with KL, and it's not a bad thing, but that's also why we see a big push for modularization, and there's a lot of benefits to it.
So where are we in the journey for SMRs? For instance, are there companies already adopting SMRs in hyperscalers?
So where I see is every country is basically building power plants or starting up existing power plants and using fossil fuels. SMRs are, to my knowledge, talking to the people in the industry, some of my customers, probably won't be ready till like 2030. But the problem is they have to be ready at 2030.
They have to be. Yeah,
the client can't, it can't get to 2030 and it be 2031. That is the
How
big
close we are.
That's the challenge because they're it's speed to market. So you can't get down a certain road and then decide to build an entire power plant and not be able to do that. And I do think that SMRs are it will be the future for. I just don't know anything right now that could do that. Hydrogen, it's a little bit more of a challenge. SMRs just seem to be cleaner.
Okay.
So
So before we go to an audience round of questions, I want to know, Jake, what would you advise a company who's trying to balance between the usage metrics, the ESG, and the challenges of cooling? Where is the kind of a middle ground or the trade-off they got to do?
So it's going to be site specific. Whether
Again, you mentioned that. That's
yeah. I would say that what you'll see in KL is what I've seen in other regions is, in areas where you use a cooling tower, you're going to use an adiabatic cooler. And it's because you have the extra power, but you don't have the water. And in some regions, you probably still use a cooling tower, but because you have the water, you might not have the power, so you can save on power. I would say the one constant will be sustainability. With the size, and we just saw the presentation before. Right now, AI data centers are taking up 7% of the world's electricity. So, sustainability is going to be huge. And I would say we're not going to meet, most any company, it's going to be very difficult to meet 2030, 2040 goals. And they're going to have to start looking at disruptive technology to become almost net negative. And there was an article in Canada where Meta and Microsoft, so it's public information, they're not even using steel. They're using wood to build some data centers. and we've had a lot of clients ask us for modular systems using green steel, so it's not coming from using the standard process, but using a green process to make it, even though it's more expensive. But they're getting that much pressure that they have to look at it.
Unbelievable.
Yeah, it is. It really is.
So what about the concrete, the embodied carbon in the concrete? You said about steel, but how do they account for because data centers are huge structures, right?
Yes.
And how do you account for the embodied carbon in the
I believe that's a daily struggle for them.
daily struggle?
Yeah, but some of them are so large. I mean, the amount of infrastructure is so, you just can't believe it. And building in areas where you got to build roads, building in areas where you got to, basically build out a city. So it's really it's going to be an exciting journey. And KL is a great place, and it's very much reminiscent of what I've seen, like I say, in the U.S. And it's going to come to India as well, like I mentioned before. Southeast Asia is prime, and Malaysia specifically, Singapore too.
Thank you, the panel.